Hey everyone, today let's discuss question 238, product of array except self. This is part of our playlist on Blind 75, where we'll go through the Leetcode questions on YouTube. Alright, so let's begin. So in this question, we are given an integer array nums, and we want to return an answer array such that answer of I is equal to the product of all of the elements of nums except for nums of I. And we want to do this using O of n time. So let's take a look at example to see if we can better understand what this question is saying. So basically, in this question, we have an input of nums, and we want to return an array which is of the same size. Now, let me just space this out so we can probably see what's happening here. But basically, the way you can think about this is that, and I'll actually write the indices right over here. Easier to see. So this is index 0, 1, 2, and 3. Now, at index 0, we basically want the product of all of the elements except for the one at index 0. So at index 0, we want the product of 2, 3, and 4, and we don't want the product of this one included because it's part of the same index. At index number 1, we want the product of this multiplied by this and this, and you can see that it gives us 12. At index 2, we want the product of index 0, index 1, and index 3, and you can see that gives us 8. And finally, at index 3, we want the product of these three indices, and you can see that gives us 6. So basically what this question is saying is that we want a regular product, but we don't want to consider the existing index as part of the product. That's where the except self comes from. And you can see that in the second array over here, it's actually very intuitive why this is happening. You can see a bunch of zeros except for the one right over here. Now you can see here, the reason there's not a 0 is because when you're here, you're taking the product of these two and these two, but you're not taking it of yourself. So there's no chance that a 0 can happen. And you can see the 0 in the rest of the positions, because at any of these, we'll always be considering the 0 here. And so that's why there's going to be 0 everywhere else. So what's a way that we can kind of do this? And you might already think of a O of n squared approach, which involves like two nested arrays. So let's kind of see how we can do that. So let's say we had like an array I and j, right? So we can have something like this. So for I in range, 0 to length of nums, and for j in range, 0 to length of nums, right? So what exactly do we want to do? Well, let us have that I will control our answer index, right? So let's say answer is going to be our array, and we know this array is going to be of size nums, right? So we can already say this. Now, what should be the starting value of the array, right? Like, what should I put here? 0, 1, 2, 3, like what should I put here? Well, if you think about this, when we're doing a product, right? Any type of product, you always want to start off your arrays with 1, because 1 times anything will be that anything. Similarly, when you're doing like a sum, you always want to start off with 0, because 0 plus anything will be that anything. So here we can just start off our answer with a bunch of 1s, right? Now, what exactly is happening here? So I will be the index in the answer array. So what we want is we can do pass over here, but basically once this is done, we want to do I of answer, or answer at I is equal to some sort of value over here. So what exactly is this value going to be? Well, that's going to be determined by j, right? So j is going to cycle through 0, 1, 2, 3, and it's basically going to keep a cumulative product of all of the elements that are happening. So when I is equal to j, we actually don't want to consider this case, right? Because it should be except self. So we can do something like, if I does not equal j, then we're going to do something. So let's say I is at 0 and j is at 1. So basically what we want to do now is we want to multiply this 2 with whatever is the existing product so far, right? Well, we can store that in a variable. So let's just say product is equal to 1. So we'll just start it off at 1 here because that's where we start off all of our products. Our sums start at 0, our products start at 1. So when j is over here, we can do something like product is equal to product times nums at j. So now product will be equal to 2, then j will move here. Then product will be equal to 2 times 3, which is 6. Now j will move here. Then product will now be equal to 6 times 4, which is 24. And you can see that's exactly the answer over here. So now here I can just do answer at I is equal to product. And then I will move forward 1, right? But j will start back at 0. And then again, here we will do 1 times 1 in this case, actually. And then you'll skip this because it's the same index. Then we'll move it here. You'll do 1 times 3, so it's going to be 3. And then I'll move it here, and then it'll be 3 times 4, which is going to give you 12. You can see that this is a O of n squared approach of doing it, and then we just return answer in the end. And I'm just going to go ahead and run this on our sample code. our sample test cases, I'm sorry. So it should all pass. And basically, after we submit it, we should see that most of the time it passes, but the main thing that happens is we get the time limit exceeded error. And so that's why they want us to do this in O of n time, so we don't get this error. So once we get that, let's take a look at how we can do this in O of n time. Right? So what exactly are we doing here that's not needed, right? Like what exactly is the the time being used on? If you think about it, we're resetting j to 0 every single time, right? Like I is advancing from 0 all the way to n, but j is always starting at 0 again, because we need to consider the left-hand side and we need to consider the right-hand side as well. So let's see if we can maybe make this a little bit easier. So let's say we have a bunch of items in the array, right? I'm just thinking of random items right now. And let's say we want to consider, we're over here, right? So we want to figure out what is answer at this position over here. Well, it would really be helpful if somehow I could store what is the answer up to this value. So like what is the cumulative sum on the left hand side of this, and what is the cumulative sum on the right hand side of this? Because if I knew that, then basically all I needed to do was that this position would just be equal to left multiply by right. Right? So if you think about this simply, so let's say we had, let's say, so which index is this? This will be index 0, 1, 2, 3, 4, 5, 6, and then we'll just call this index 10, right? So basically, answer at index 5, this is essentially, we want it to equal whatever the multiplication of these values is, multiply whatever the multiplication of these values is. So let's say this is equal to left at 5 times right at 5, right? Left at 5 should be equal to 2 times 3 times 1 times 5 times 2, and right at 5 is equal to 1 times 5 times 2 times 6 times 1. And you can see that we're actually doing the same thing we're doing here. It's just that we're storing this information. So j doesn't have to start all the way at 0 again, index 0, and go through the entire list again. We're rather storing that information in an array. So how exactly can we do this? Let's think of a simpler array. So let's say we had like the array maybe 2, 1, 3, 1, and 2. Let's do something like this, right? And then we'll store indices, so 1, 2, 3, 4. Now, what is equal to answers at 2? Well, answers at 2 will equal to left at 2 times right at 2, right? Now, what is left at 2 and right at 2? Well, left at 2 will equal 2 times 1, right? It'll equal these values here. And right at 2 will equal 1 times 2. And you can see that this will give us the answer that we need, right? It's exactly the answer that we need. If we want to consider this one, it's basically going to be left at 3. Left at 3 is going to give us 2 times 1 times 3, and it's going to be right at 3, which would just be the number 2. So that's basically the approach we're going to take, and the question now is, how do we calculate this left at 2 and right at 2? Or rather, how do we calculate the left and right arrays? Well, let's think of a simple approach here. So what is left going to start off as? So you can see here, we started off answer as just 1, right? So I think we can do the same thing here. So 1, 1, 1, 1, 1, right? Now, what exactly is left encoding? Think about the meaning of left. Left is basically saying that if I'm at any index, I will give you what is the multiplication on the left-hand side of this, right? So let's just go through this. So what should be left at 0? Well, left at 0, if you think about it, what's on the left-hand side of 2? Well, there isn't anything, right? So the multiplication here should just be 1. What's on the left-hand side of 1? Well, the left-hand side of 1 will just be equal to whatever's on the left-hand side of here, of 1, which is just this index over here, right? So it will be 0. Or I'm sorry, it will be 2. What is equal to left-hand side 2? Left-hand side 2, well, this will be basically these two values here. Now, no, we already know what is left-hand side of 1, right? We already have that information here. So what does left-hand side of 1 tells us? Left-hand side of 1 tells us what are the values, or what is the product up till this point, like up till this point, right? So what we can do is we can take left-hand side of 1 and multiply it by whatever's at nums at 1, right? So we can do left-hand side of 1, multiply whatever is at nums at 1. Let's keep going. Left-hand side of 3. So what is left-hand side of 3? Left-hand side of 3 is basically, we can take the left-hand side of 2, which will give me the multiplication of all of these elements here, and then simply multiply it by whatever's at nums at 2. We would do left at 2, multiply by nums at 2. And this will give me left at 3. Now left at 4 finally, is basically going to be all of these values here. Well, we already know what all of these values are. This is simply equal to left at 3. And then to get the value of all of this, we'll just do left at 3 times nums at 3. And that's how we get the left array. Now similarly, we can do the right array, which will also start off all at once. Now, if you think about the right array, it kind of makes more sense to start off looping in reverse. So we'll create the array from the right hand side backwards. So really we want to consider right at 4, right at 3, right at 2, right at 1, and finally right at 0, right? So what exactly are these values? If you think about this, right at 4 is basically equivalent to left at 0 because there's nothing on the right hand side of the fourth index. There's nothing on the right hand side of 2. So this would just be equal to 1. What about right hand side of 3? Well, right hand side of 3 is basically just equal to this value over here, right? Which will be right at 4. Now, what is right at 2? Well, right at 2 will essentially be equal to, we want it to be equal to all of this, right? So like all of these values here, all of these values here. So we can do that. We can first figure out this one, which will be all of the values here, and then we multiply it with right at, or nums at 2. So this will be nums at right at 3 multiplied by nums by 3, right? Right at 1. So what is this value going to be? Well, this value is going to be, we want it to equal all of this. So what we can do is we can figure out right at 2, right? And that will give us these two values here. And then we can multiply it with this value here, which is nums at 2, to figure out what's right at 1. And finally, similar approach here, we'll do 1 and then nums at 1. So now we have the array. And if you think about it, what exactly this allows us to do is that whenever we want to figure out, like for example, what is answer at 2, all we need to do is we need to figure out what is the product on the left hand side, what is the product on the right hand side. And we get that by doing left at 2 times right at 2. And you can see here that just by using a couple of arrays, we're able to make this into an O of n time algorithm. So now let's go ahead and code this. So again, the idea is exactly the same. So what we will start off by doing is, let me just zoom in here, and I will delete all of this. So answer will just be 1, and this will be times length of nums, right? Now, let's create a left hand side first. So we'll create the left, and then we'll create the right. And you know that the left is simply equal to, again, the same, and then the right is also equal to the same. We'll do these one by one. Length of nums, right? Okay, so what is the left equal to? Well, left is equal to exactly what we calculated here. Now, you should note something, that we don't necessarily need to calculate left at 0, or we don't need to calculate right at the ending element, because they're always going to be 1. So we can actually start off this loop by the first index, and we'll go all the way to the right hand side. And then similarly for the right hand side, we can start off at not the last element, but the element just before the last one. So we can do, this will be length of nums, not minus 1. Minus 1 would be the last element, minus 2. And then we'll go all the way to 0. Right? So this will loop from right to left. This one will loop from left to right. Okay, so now that we're here, now what is answer of I, or I'm sorry, not answer of I, what is left at I going to be? Well, as we indicated here, left at I, if this is our index over here, right? This is our index. This is our index number 2. Left at I will simply be left at I minus 1 times nums at I minus 1, right? Exactly what we followed here. And similarly for this one, right at I will be equal to, we're just adding an index, so it'll be right at I plus 1 times nums at I plus 1. Now once we have this, basically what we can do is that we can finally loop to create our answer array, length of nums. And now what is answer at I? So answer at I is equal to left at I times right at I. And that's all there is to it. And then in the end, we'll just return answer. So let's go ahead and test this. See if I've made any mistakes. Haven't. Awesome. I believe this test case, okay, that's all good. Let's just go ahead and click submit. And awesome, it works out just fine. Now, there is something, a follow-up, which I didn't really do, because I think this is a good enough answer. But if you were to look at this, this is basically an O of n time O of n space. So it's pretty much as good as we can get, and this is just a follow-up that you can think about or looking to discuss. All right, thank you for watching.